get straight to it. Good morning. Welcome. This is our keynote speech by Antonio Yunez Naude. He'll have 20 minutes for his presentation and then 20 minutes for a Q&A, and then we will listen to the rest of the panelists. Dr. Yunez got his PhD at the London School of Economics and Political Sciences in London. He is a professor and researcher of the Center of Economic Studies, Colegio de México, and a founding member of Desarrollo Alimentación Sustentable, an civil organization. He's a third-level national researcher. Thank you. He has recently published with Dr. Lando Solano, The Impact of Climate Change in the Mexican Rural Economy, a general approach published by Colegio de México as a working paper this year. He is also co-author of The Economy of the Mexican Countryside, Trends and Challenges for its Development, published last year. And he published The Cost of Production with J.E. Taylor, Chapter 14, of a book published by J. Taylor and Matthews Filipski. Impact Evaluation by Oxford University. Without any further ado, the floor is all yours. Okay.
¿Podrían ponerla? Ok. La que sigue, tenía muchas gracias al INEGI y a la UAM por la invitación, y tenía preparado media hora, pero voy a tratar de ajustarme, o me voy a tener que ajustar a 20 minutos, así es que voy a pasar algún. Ok, gracias. Y de todas maneras, algunas diapositivas las voy a pasar rápido, son más bien visuales, y y la presentación ya la dejé aquí a los colegas de la UAM. Es un poco más larga, hay más ejemplos de modelos micro de equilibrio general, y los que estén interesados pues pueden solicitarlo. La que sigue. La que sigue, por favor. Perdón, con razón. ¿Y cuál es? Muy bien. Bueno, yo creo que la mayoría.
Very quickly, I'll speak about the general equilibrium approaches for the analysis of public policies and planning. And as I mentioned in the title of my presentation, I will speak about a case of an applied model. All of the general equilibrium applied models refer to the Mexican countryside, the Mexican agricultural practices, and I will speak of a model of general equilibrium for the whole economy, emphasizing the agricultural sector in Mexico as an example of a general equilibrium model and its connection to climate change. The other type of model is more microeconomic, and I'll explain why we consider it microeconomic. And the last one, I'll very quickly speak of this because Dr. Dyer, in one of the next presentations, will be more specific about those models that are even more disaggregated, more broken down. And well, that's the rest of the components of my presentation. Many of you already know that one of the features of multisectorial models, including the general equilibrium models, are the complete effects of exogenous shocks that can go from public policies all the way down to a currency devaluation, which is something that we explore for the peso devaluation and the effects of rural migration. In terms of migration decisions and how families make the decision to migrate. Another example is the one I have here, and that many times as many of us are aware, based on the results, sometimes the indirect effects are larger than the direct ones, and this is also reflected by the multisectorial approach and general equilibrium models. Very well. And here are some of the reasons why we went from general equilibrium models, the macro ones, to the micro ones. And here are the reasons that I will be explaining during my presentation when I speak of the results from the microeconomic models. I'm referring to the book mentioned by Milne Experience book. In the beginning of this book, there is a paragraph where different models are presented for different countries, developing countries, and there is a discussion of those general equilibrium models that tends to start a conversation considering the quasi-experimental approaches to study the impact of public policies. Here are some features that in a way make this superior to the quasi-experimental model, and I'm referring to the first type of models. So let's speak about the first example. I'll be very quick, I apologize beforehand, but our time is limited. This is a model that we created a while ago for a big project of the World Bank. It was a water project in Mexico, and I don't know whether the reference is here, but you'll find it somewhere in the presentation. The study was published as a book by the Fondo de Cultura Económica, publishing number 100, including the results of the general equilibrium model applied to the agricultural sector and emphasizing the use of water and irrigation practices. And those are the reasons why the study took place. And also the reasons why, the explanation, and one of the most important encouragers was that irrigation agriculture and agriculture as a whole in Mexico and other countries is the one that is consuming the largest amounts of water, in contrast to the expectations of climate change to reduce water use. And in Mexico, there's an overexploitation of the aquifers. This is something that is reflected here. Agriculture consumes 78% of all water uses in comparison to other sectors. Another important thing is that since water is becoming more and more scarce, it'll be more in a conflict of scarcity. This is a map of the overexploited aquifers in Mexico, especially in the central part of the country and up to the north. Once again, very quickly, I assume that you have all worked with this information before. This is a macro matrix that we use for our agricultural model by using 2002 information of the input product matrix created by INEGI, and we included some additional information. This is a disaggregation of the model. We're emphasizing agriculture, and we also broke down, based on the information that we had on the main agricultural products. Something else that we did was that we subdivided agricultural production into seasonal and irrigation practices. This is a disaggregation of household use and the institutions considered for the model. Once again, very quickly, to exemplify the effects of a simulation, we did two simulations. One of them was to charge irrigation water, because in Mexico we don't. And the other one is the one you see on this side. Let me see. Yeah. The reduction of water supply for climate change reasons or the competition amongst the sectors for the resource. Here we have the results, and I insist this is just an example of the things that we can get to know based on an exogenous impact analysis of reducing use by different simulations. In this case, it was a 50% reduction. One of the two results that are more outstanding and that I'd like to point out is that there's a distributional effect. Households, especially the households of irrigation farmers, the ones who have the largest income, are the ones that are more widely affected. The general effect of agriculture and since its relevance in the whole of the national economy, it doesn't affect the GDP so much, but we do see that there is a distributional effect due to water reduction in comparison or affecting the upper echelon of farmers. Another part of the simulation that's interesting is that we measure the price of irrigation water based on a shadow price, and also this is something done by a student of mine based on the calculation of the seasonal and irrigation land to measure or lease information, something that is not obtained through official sources. And in this case, we also took in consideration the changes after the reforms where irrigation water users associations were created. One of those institutions is one of the agents presented here. We did a simulation, and one of the effects of the shock is that the income of those associations go up, and that means that it is possible that by this increased income to invest on irrigation infrastructure that can be using water in a more efficient way. This is the reference, and whoever wishes to explore this can consult this information. The other example is the household models. And I exemplify this according to the prediction of B general equilibrium models had predicted. The models that were created during the beginning of the 1990s to assess the possible impacts of free trade agreement in North America and the Mexican economy. The same thing was done for Canada and the US, and those models were also applied to Mexico. As you might remember, those of you who are as old as I am, or perhaps a bit younger than myself, back then there was a very big controversy on the effects, and based on the results there was also a big concern about the effects of incorporated into Mexican agriculture into the NAFTA agreement, especially in comparison to the advantages that US or Canada had. Corn was one of the main concerns. The prediction through the use of big models for agricultural purposes was that the prices, the goods, would nosedive, especially the least competitive ones, including maize, corn. What happened at the end is that the prices would go down. This is something that was foreseen for the basic farming practices are not competitive, including corn. But there was no nosediving as was predicted based on the models. Therefore, we developed the microeconomic models so as to understand the effects of reducing corn prices, considering different features that were not considered originally by the big general equilibrium models. And that is the type of consumption, the features of the practices, household usage, which is not only something that happens in Mexico, but in other low-income countries as well. This is a George Dyer illustration, and I'm sure you'll learn it by heart. What is the micro general economic level equilibrium models reflecting, depicting? This is a household. And one of the features of those models, what we are incorporating is the transaction costs. So let's suppose that there's an exogenous shock, there's a reduction of corn prices, but this only affects the households that sell corn to the market. So in that case, the effect comes from, there's a direct impact in certain households that are not only producing corn, but also part of the production is self-consumed. Part of that is sold, and part is also used to feed livestock. That is the illustration. But perhaps, and this is something that the models also express, that there are indirect effects, other households within the same community, for instance. People who, even though they produce corn, they do it for their own use. They are not connected to the market, but perhaps they might be connected to households who are directly affected. They lease the land from them, or they share labor market, and part of those households that are not connected to the market might be wage earners or other people who are directly affected. And like with other general equilibrium model, this shows the direct and indirect effects of the economy. Very well. Those are the features of the model that we use. There are two relationships. I do not know whether a simulation of increase of corn prices that George Ryer did later included similar features to our study, but basically this is the type of considerations that we do in the general macroeconomic equilibrium models. A fundamental aspect, as I have shown before, is that there are certain households who produce for their own consumption, especially corn. Some others sell the production, and so we subdivided the households according to that feature and the size of their lands. And there are other households that are non-producing. Something else that is reflected by this type of models is that there's a diversification of income sources and activities. We model international and national migration as one of the possible household activities for which part of the labor is devoted because prices are paid for transportation, and the royalties or the income comes through remittances. All of those models, and at the end I'll refer to this once again. As you are all aware, the big, small, and middle-sized models are very demanding in terms of the data. We were able to model this by having surveys to obtain this and other econometric data. This is how the social accountability matrix was elaborated. It is reflecting the whole economy. For instance, in consideration of international aspects, we included remittances of the migrants to the original households. This is another way in which we are illustrating a recent survey by Coneval, who is an institution that measures poverty and does this type of assessment. Here I'm presenting the diversification of activities and income sources of rural households. How much time do you have left? You still have time. This is a model that incorporates the consumption and production decisions of the households, and part of the profit maximization considers income restrictions, technological limitations, and others. The solution of the model, as other general equilibrium models, provides the demands of labor, land, and others. Another important contribution of this type of approach that can partly explain why other models that do not consider this were not accurate in their predictions, in their forecast, has to do with price modeling. Who's affected, who's not affected. And in the micro models, we have different price ranges. Commercial producers, and this is something worth mentioning. All of this comes from additional information that we got. This is not something that we just pull out of our sleeves. So there are two types of households. One of them are the commercial households. And based on the database that we have, they have more than 5 hectares for their production. And the prices, the first ones in household use, are directly affected by price changes. And time changes or price changes are exogenous, and they come from, for instance, information of U.S. prices. We have econometric analysis of price convergence, and there is evidence that after NAFTA, there was a convergence of prices of crops such as corn, the most important one in Mexico, in comparison to the U.S. prices. And there are other households that have less than 5 hectares. Those are considered to be as survival practices for family consumption. And there's a shadow price used there based on the supply and demand of each household. Speaking of other prices and considering other elements, the price of land ownership and labor is determined by the rural environment itself. And we know that wages in the rural environment are lower than in cities. That was also modeled, and the rest of the prices are exogenous. There are many different types of illustrations. Very quickly, the ones that are in italics, I'm explaining the different simulations of the model, the different types of model. Number 1 and 2 are the same model or a similar one. The third one is a PhD study that was recently concluded by a student of ours on climate change. And point 4 provides the information. George Dyer will give the information. I just exemplifying that this is a very microeconomic model. Each household is modeled separately. And the general conclusions, the effects of the shock when remodeling corn prices, and how this is dependent on household participation in the markets. Well, that's basically the general aspect. I don't want to go into further detail, and he's walking away from the microphone. We can barely hear him. And well, those were the households that were incorporated to the market, and we see how the effect of corn price drop, was of a 12% almost, and this is something that doesn't happen in the rest of the survival practices. This is what I've just explained. And so with this illustration and the explanation of why, let me go back on my tracks. I'm running out of time quickly. Okay. This is how the small households are affected by the reduction of corn prices. This is reducing commercial production, and this is also breaking down land leasing and production and wages, and so more households are producing for survival purposes. I don't have time for elaborate further.
Voy a ilustrarles muy rápidamente el otro modelo que hay, que es
Another model
como una ilustración adicional.
that is an additional illustration of this type of studies that can be done around impact, things that we can do from microeconomic general equilibrium models include what we know so far of the effects on climate change in agriculture, like the measurement of productivity effects. This is what a colleague from CIME has estimated for corn. And what we do is simulate the reduction in productivity due to climate change reasons for the next 30 years or so, for the year 2050. The estimations differ according to productivity effects, climate change variables. They are different from each region, and the general equilibrium effects are also different. During the last table, I present a summary where the compensation variables are measured, that is to say, the resources that are necessary to keep the same level of income for those households that are negatively affected by climate change through changes in the productivity rates. Those are the figures. They vary according to the region, but they amount to billions of pesos that would be needed to help them compensate the losers of climate change effects. What are the options for policies? That is what we're currently exploring. Adaptation and mitigation policies for climate change is what we're considering. Unfortunately, I have no more time to present this explanation, but luckily George will be presenting the agents models. Those models are much more microeconomic than what I presented here. I don't go into so much detail, but I gave you a general perspective of the effects that are very clear in different households throughout various regions in the country. Another feature that we know of general equilibrium model is that there is a counterfactual effect. If you eliminate the prices or the subsidies of Procampo and you use them to increase productivity in the rural area, and the effect of the second type of measurement would be higher for production and household income. To wrap it up, something about the data. I feel very pleased that INEGI is participating in this effort. And as we know, it is very important for us to have INEGI's information, the one that is created precisely for this type of analysis that is much more disaggregated and more updated as well. And I'm skipping this. This is some of our current work based on general equilibrium models in the macroeconomic sphere and some future possible research that we will be doing. Thank you.
Any questions? Does anybody have a question? I do have a couple, Doctor. I work for INEGI and I work with INEGI databases. And one of the problems that we have faced, especially when it comes to water supply and water distribution for human consumption, has been precisely the difference in the geospatial zoning of the areas. For instance, Conagua uses geographic areas that cover more than just the state because they base on their studies on basins. But we work with very specific regions that don't really overlap. So the data produced, the information that you're using of households doesn't really match with the hydric regions that we use. So how do you sort this problem? Can you hear me? Well, unfortunately, we haven't been able to overcome this problem. The information that we used was from the data that came from consumption for irrigation, and we only used superficial water, not deep water, and that's precisely because of the difficulty getting that data. We also did that because I'm sure you remember that there's an agreement on water use with the US. So we set apart the basin of the Rio Grande, but that's about as much as we could do. And something else that came up that, and it's very good that you asked this question to be able to address this, is that we held a meeting with colleagues from the University of Texas, the A&M, with some engineers, and the proposal was to incorporate general equilibrium models, that is microeconomic models, with hydrologic models. And for the case of the Rio Grande, they had very detailed information about the basin, about the river, and how water is distributed to several regions and areas. But that's about as much as I can say. And in this model, we couldn't really get information on the competition between the rural areas and different uses. And that is indeed very important. We are also looking into climate change effects on agriculture, and there has been some progress. I can actually share research that I was reading about finding a balance between a general equilibrium model. Any other questions? Hello, thank you. It's a very brief question, well, two questions actually, about your criteria to determine how to figure out households of more than 5 hectares or less than 5 hectares. Then for self-consumption, the variable about unpaid work or not, did you consider that? Okay, great. It's not an arbitrary division, the size of the area. We took into account data and observation of surveys, but of course it can be considered a little bit arbitrary. But the progress that we made was that in this model we took non-agricultural producers and we included them in the same category of households. What we have done more recently is to separate them because there are households of teachers or public officials combined with very small-scale production, which is a family farm or someone who's leasing their land. So we decided to use size, but it is rather arbitrary, precisely because it's very hard to find a way to subdivide the areas. But George Dyer is now working on agent models, which is that every single household is considered separately. So that can help to avoid grouping together households that shouldn't be grouped together. He will probably be doing this, I'm not sure, but George can group them based on the impact of an exogenous factor instead of doing it beforehand. Regarding work, unpaid work in the household, it's a whole discussion. It's every single element that is not a part of the market is a whole issue. It's, for instance, the value of land, the price of leasing the land, and everything that we call the shadow price of the country for subsistence. In this model, for instance, the climate change model, which is the most recent one, we didn't manage to disaggregate. We could estimate, based on the data gathered in the survey, the income as the net income considering the use of capital and land in a household, but we haven't been able to disaggregate that data. So the way to estimate that value is by assuming that that value is the same as the marginal production of each one of the factors, which is what we do in economics to determine wages, for instance. So they can be estimated econometrically, the prices paid to each of these factors. Especially for the case of corn, to measure net income, which is the value of production, including self-consumption, minus the costs. If we find, for instance, the local wage, and we consider unpaid family work, it turns out that the net income for corn production in many cases is actually a negative figure, which, as you may imagine, those of us who work with general equilibrium models, is absolutely inconsistent with economic theory and with reality. But thank you for your comment, because this is a very important aspect that needs to be taken into account, needs to be estimated, the value of unpaid family work. There's a doctoral thesis that was recently done in Colegio de Mexico that measures, based on productivity, the value of family work, which is actually less than the current local wage. Thank you very much. We are out of time, so I want to give you your acknowledgement, a diploma for being here with us. Thank you very much.